All right, today we are diving into one of the greatest intellectual detective stories in all of human history. It's a revolution that literally moved the Earth and completely rewired how we see the universe and our place in it. So, let's get into it and start solving this cosmic puzzle.
So here's the core mystery we're unpacking. For over 1,400 years, the idea of a stationary Earth wasn't just, some popular theory. It was considered a fact. It was backed up by common sense, by philosophy, by the best mathematics of the day. So, what happened? What kind of evidence could possibly be powerful enough to overturn everything that basically everyone knew to be true?
To even begin to solve this puzzle, we have to start where everyone else did, with the original model. And look, this thing was brilliant. It was logical, and it was an incredibly long-lasting framework that placed us and our planet right at the very heart of creation. And this is the idea, right? Geocentrism. It's so easy to see why this made perfect sense. I mean, just go outside and look up. The sun, the moon, the planets, the stars, they all look like they're circling us every single day. For the ancient world, this wasn't really a theory. It was just an obvious observation. It was a daily truth that needed to be explained, not challenged.
Now, this is where it gets really interesting, because you had two powerful systems that locked together to make geocentrism feel, well, unshakable. First, you had Aristotle providing the physics. He argued that heavy things, earthy things, naturally fall to the center of the universe. And since Earth is clearly the heaviest thing around, it has to be the center. It just makes sense. Then you had Ptolemy, who came along and provided the incredibly complex math, using these wheels within wheels to predict, with amazing accuracy, exactly where the planets would be in the sky.
But there was a glitch in the system. Every so often, planets like Mars would do something really weird. They'd appear to stop in their path, move backward for a little while, and then continue forward again. We call this retrograde motion. And to make the math work for that, Ptolemy's model had to get unbelievably complicated, adding more and more circles on top of circles. It was accurate, for sure, but it was starting to feel kind of clunky, a bit messy.
So, how do you even start to unravel a 1,400-year-old idea? Well, you start looking for clues. And the first major clue was this totally radical idea, one that was proposed way, way before Copernicus, and then it was almost completely forgotten. It was an idea that put the sun, not the Earth, at the center of everything.
Okay, so what's with this number, 87 degrees? It comes from an ancient Greek astronomer, Aristarchus of Samos. He was trying to figure out the sizes and distances of the sun and moon. And through some really clever geometry, by measuring the angle between the sun and a half moon, he calculated that the sun had to be way farther away, and therefore it had to be much, much bigger than the Earth. Now, his measurement was a little off, but his logic was absolutely sound.
And this right here, this is his brilliant insight. If the sun is this giant fiery ball, and the Earth is just a speck in comparison, doesn't it just make more sense for the little speck to orbit the giant? It was the first truly sun-centered, or heliocentric model. But it was completely rejected. And why? Well, because it flew right in the face of Aristotle's physics. If the Earth were really hurtling through space, why wouldn't we all just be flung off? It was a question nobody had an answer for.
Okay, now we're going to jump forward almost 1,800 years to a Polish cleric who dusted off this ancient clue. His name was Nicolaus Copernicus. And what's so fascinating is that he wasn't really driven by new observations or new data. He was driven by this deep desire for a simpler, more elegant, more harmonious design for the cosmos.
Copernicus's system was just revolutionary. By putting the sun in the center and having the Earth orbit it, so many of those nagging problems just disappeared. The daily motion of the stars, oh, that's just the Earth spinning on its axis. That weird retrograde motion of Mars, turns out it's just an optical illusion. It's what happens when our faster Earth overtakes a slower Mars in our orbits, like passing a car on the highway. Suddenly, the universe had this beautiful, unified logic to it.
So, how did this world-changing idea even get out there without causing an immediate uproar? Well, this is the crucial part. A theologian named Andreas Osiander added this little preface to Copernicus's book, without his permission. By framing the whole thing as just a handy mathematical trick, not a claim about how reality actually is, he made it possible for the book to circulate among scholars without immediately starting a war with the church. It was a clever move that protected the work, but it really just delayed the inevitable conflict.
For about 60 years, Copernicus's idea stayed mostly in the realm of a mathematical curiosity, an interesting thought experiment. But then, a new invention showed up that would provide the smoking gun, the hard, observational evidence that was needed to finally solve our puzzle.
But first, before we get to that, let's look at this really fascinating compromise from the great astronomer Tycho Brahe. Now, Tycho loved the mathematical elegance of Copernicus, but he just could not get his head around a moving Earth. So he proposed this hybrid system. The Sun orbits a stationary Earth, but all the other planets orbit the Sun. It was a really clever attempt to kind of get the best of both worlds.
And then came Galileo. He pointed his newfangled telescope at the sky and just shattered the old universe piece by piece. First, he saw mountains and craters on the moon, proving the heavens weren't some perfect, unchanging realm. Then, he saw 4 tiny moons orbiting Jupiter, which proved that not everything in the universe orbited the Earth. But the killer blow, the real checkmate, was Venus. He saw it go through a full set of phases, just like our moon, and that was absolutely impossible in the old Ptolemaic system. It could only happen if Venus orbited the Sun. Game over.
So while Galileo provided the proof that the old system was wrong, it was Johannes Kepler who wrote the new rules of the road for the cosmos. He used Tycho Brahe's incredibly precise data and realized something huge. The planets don't move in perfect circles. They move in ellipses. And with these 3 beautifully simple laws, he swept away the need for all those complicated epicycles for good. He created a model of the solar system that was, for the first time, both incredibly simple and stunningly accurate.
Okay, the puzzle was almost complete. We knew the Sun was at the center. We knew how the planets moved, thanks to Kepler. But the ultimate question, the biggest question of all, was still hanging out there. Why? Why do they move in this specific elliptical way? The final piece of the puzzle was about to fall right into place.
And this is the profound genius of Isaac Newton. He realized that the force pulling an apple down to the ground was the exact same force reaching out across the vast emptiness of space, holding the moon in its orbit around the Earth and holding all the planets in their orbits around the Sun. It wasn't 2 sets of laws anymore, one for down here on Earth and one for the heavens. It was one universe, all governed by one single elegant law.
And this is how Newton just tied it all together. His law of inertia finally explained why we don't feel the Earth moving beneath our feet. His law of universal gravitation provided the physical cause for Kepler's elegant ellipses. Those ancient objections that had completely stumped Aristarchus were finally and completely solved. The Earth could move, and it did.
So the puzzle is solved. But you know, the story doesn't really end there. Because the solution had this profound philosophical consequence, one that we are still grappling with today. It was the beginning of what's been called the Great Cosmic Demotion.
This is the lasting legacy of this entire revolution, the Copernican Principle. It's the simple but powerful idea that there's nothing special about our vantage point. We are not privileged observers at the center of things, and this principle has become an absolute cornerstone of modern science, always pushing us to see the universe as it really is, not just as we'd wish it to be.
And this chart really shows how that first step by Copernicus was just the beginning. Later, astronomers like Harlow Shapley discovered our Sun isn't even at the center of our own Milky Way galaxy. And today, modern cosmology tells us that the universe itself has no center at all. With each major discovery, we've been moved further and further away from any kind of special, privileged position. And just to show how science is always refining our understanding, we now know that even the Sun isn't perfectly stationary. Turns out the Sun and all the planets are in this constant gravitational tug-of-war, and they all orbit a common center of mass, called the barycenter. Because Jupiter is so huge, this point is sometimes actually outside the surface of the Sun, which means our star has its own tiny little orbit. Which brings us to our final thought. This 2,000-year journey of discovery moved us from the absolute center of everything to a small planet orbiting an average star in a pretty nondescript corner of one galaxy among billions. We are not the center of anything. So, what does that make us? Well, maybe it makes us something even more remarkable. A curious, intelligent part of the universe that is capable of looking out and actually understanding its own incredible vastness.